Okay, in this video, we find the absolute maximum and minimum values of a function over the given interval. And the interval is a closed interval, so that means that it's an interval that's a finite interval, a bounded interval, I guess I should say, and includes the endpoints. We're going to use the closed interval method. Some books call it that. And what we do is, step one is we find the critical numbers. Okay, so what are critical numbers? Critical numbers are numbers in the domain of the function. So they have to be in the domain of the function, and either the derivative of that number is equal to 0, or the derivative of that number is undefined. But let's just go ahead and do this, and as we go, hopefully it'll unfold. Now, the thing is that I am going to express f for the function as powers of x. So x squared plus 2x to the minus 1. I'm doing that, especially the 1 over x is x to the minus 1, so that I can use the power rule, sort of one of the easier rules to use. The derivative of x squared is 2x, and then the derivative of x to the minus 1 is minus 1 x to the minus 2. So I have 2x minus 2 over x squared. Now, first of all, I'll just do a little remark. F prime of 0 is undefined. So that makes me think, oh, okay, got a critical number. But 0 is not in the domain of the original function. It's not in the interval from 1 to 4. I mean, in fact, the domain of this function, regardless of the interval, would be all real numbers except x equals 0. So anyway, 0 is not a critical number. And now what we're going to do is we're going to solve f prime of x equals 0. So we have 2x minus 2 over x squared equals 0, because that's the derivative. We can find a common denominator. And by the way, this isn't the only approach to do this, and someone say, no, I don't do it this way. Another way to do it is you have two terms that are separated by a difference. So you could write this, and maybe it's even better. I mean, I feel I can do it both ways. And you cross multiply, and you're going to get x to the third power equals 1, and you solve. It's either way, you're going to get the same thing. So in the numerator here, I'm going to get 2x to the third, parentheses, 2 times x to the third minus 1 over x squared equals 0. I sort of like that because it preserves what f prime is. But this leads to x3 minus 1 equals 0. x to the third power equals 1. And the only root of that equation is x equals 1. So that's our critical number. And it's what you can see is that I was overly ambitious or optimistic that I had enough space. But it turns out I don't, at least the amount of writing I'm doing here. So anyway, this is our critical number. Oh, by the way, is it in the interval? Yes, it's an endpoint. Huh. Doesn't sound that interesting. No, it makes me think I did it wrong. It's so boring if it's just that they are critical numbers, it's just one of the endpoints. It's not very interesting at all. So, did I do it right? Okay, hold on. The derivative of x squared is 2x. The derivative of 2x to the minus 1 is 2 times negative 1, x to the minus 2. So plug in 1, that certainly works. Well, anyway, the next step is we're going to plot points. Plot the critical numbers and the endpoints. So it turns out the critical number is an endpoint. So I have f of 1 is equal, and remember, don't plot that into the derivative. We want to plot that into the original function, which I may have written down wrong. What is it again? Oh, no, yeah, sorry. I did write it down wrong. X squared over 2 over x. Okay. So f of 1 is also, it could be hard to determine, but I think I can do this. 1 minus 2 is negative 1. And f of, okay, so the interval is from 1 to 4. See, this would have been a better problem, I think, if it had been from 1/2 to 4. Might have been more interesting, but I didn't make the problem. And it's true, this is the first edition of the Openstax book. I wonder if I call them up, send an email, whether anybody would listen to that. All right, so, but we just, there's, the endpoint and the critical number are the same. So we get the absolute max is the larger of those two numbers. So what you do is you can compare. So I can write a little word right there, just a one-word statement. Compare the y values after you plot points. If I didn't take calculus, if someone didn't take calculus, they would just plot a whole bunch of points, and that's what a calculator would do. And since these are, well, especially since 1 and 4 are integers, I think the calculator would find those numbers. But what if the critical number is like square root of 2? Would the calculator find that? I think it would just find a decimal approximation. So we compare negative 1 and 31 over 2, and we just look to see which one's the greater and which one's the less number. And then what I can do is, well, hold on, what number is this? This is 119, and I have the answers here, I believe, in the Openstax. So, yeah, that's it. So, oh, no, I did it wrong, so that makes it more exciting. What? Oh, hold on, everybody. You know what I did is I copied it wrong. F of x has plus there. See? It's plus. So were you just turning off the video, or were you just feeling smarter than me? Okay, you are. Probably have more brain cells. Okay. There we go. So that was a little bit, not super happy for me that I got that wrong. On the other hand, it wasn't so bad that I feel like making a new video, because it takes a long time to make a new video. So why did I get that wrong? It's an old one. I copied the problem down wrong. I copied the function down wrong from above. I put minus instead of plus. See? It's a little bit, I think, this program, what I'm using here to do this, is I wish I could get pages side by side, but it's way up there in the top. Okay, so I got the absolute max. 33 over 2 is greater than 3, and so 3 should be the minimum. And what I did is I plot the critical numbers and the endpoints. It turned out that this critical number is the same as the endpoint. Suggestion for Openstax: make the interval from 1/2 to 4 instead of 1 to 4. I think it would make a more interesting problem. Okay, that's all.